Finding waves and flexing biceps. It's not Muscle Beach, it's the Big Bang. You've probably heard the exciting news that people at the background imaging for Cosmic Extragalactic Polarization 2, or BICEP 2, have found evidence for gravitational waves. But you might be saying, why exactly is this exciting and what is a gravitational wave? Well, to answer those questions, we need to go back about 13.8 billion years. You see, we're talking about the time of the Big Bang, the theory that explains how the universe behaved when it first came into existence. We're talking a fraction of a fraction of a fraction of a second when the universe expanded rapidly. And by rapidly, I mean it violated the universal speed limit of the speed of light. It actually went much faster than that. Now, scientists believe there should be evidence for this rapid inflation in the form of gravitational waves, something that Einstein hypothesized about in his theory of general relativity, but no one had observed any real evidence that they had actually existed. Until now. If you were able to look at space-time really closely, you would be able to see these little quantum fluctuations, ripples in space-time, but they're so small we can't actually observe them. However, during cosmological inflation, they got stretched really far and became gravitational waves. Now, no one had seen any evidence of these things until the folks over at BICEP 2, who used a telescope to look at photons, little particles of light, in the cosmic microwave background, and they saw patterns that indicated the presence of gravitational waves. This is the last observable element of Einstein's theory of general relativity. Everything else had already been cataloged, so this is incredible news. Now, scientists suggest that we should wait for other people to either confirm or refute those findings, but they look pretty promising. Now, Einstein also said that the closer you get to the Big Bang, the more the laws of physics break down, and in fact, time itself at some point ceases to exist. What happened before that? It's a meaningless question, because without time, there's no before. And I saved the best for last. This really has me excited. You see, cosmological inflation models often include multiple universes as a possibility. The multiverse theory, in that inflation where the universe expands so fast, it sets off other bubbles expanding with universes of their own inside them, each universe having its own laws of physics. How awesome is that? Now, I'll admit there's very little practical application of this information in our day-to-day lives, but I maintain that it's this kind of knowledge that will allow us to forge a path to the idealistic future. And just think, if we can learn more about how space-time expanded faster than the speed of light, who knows? Maybe in the future we'll be racking up some galactic speeding tickets of our own. That leads me to a question for this week for all of you guys. What's your favorite scientific theory or discovery? Let us know in the comments below and explain why it's your favorite. And then if you enjoyed this video, make sure you share it with your friends, hit that little like button, subscribe to the channel, then check these videos out over here. They pack a pretty big bang.